Speed time plots for falling objects are pretty much always look the same. So this is speed, and this is time, and I'm going to have up and down. So this is moving up, this is moving down, and let's imagine where we deal with a problem where I have, someone's throwing a ball in the air. They initially throw it up. It has some initial speed. The ball goes up to the top, comes back down, and comes back to their hand moving down. Okay, and so we can say the event 1 is when it leaves their hand. Event 2 is when they're at the top, and event 3 is when it reaches their hand back again. So since we're starting with at event 1 with some speed up, we are starting up here somewhere, and after it leaves their hand, there's no other influence other than gravity. And because of that, the speed decreases and decreases at a constant rate, and so that rate is a straight line, and the slope of that line is -10. The units would be in meters per second every second. That's a rise over a run. Okay. So this is a speed time plot, and as we've seen, the distance that it travels is the area under the curve, and we can label and so that the distance in this case we're throwing it up is what we would call h. So h is that area under the curve. We can call the initial speed v0 and label the different locations of these events. So event 1 is at the beginning. Event 2 is when the object is not moving at all, so its speed is 0 at some time. And then event 3 would be down here somewhere. So event 3 is again moving down at the person's hand again. We can ask a number of questions about how high it's going, what the speed is versus time. So essentially, since we have a line, we could y equals mx plus b. So the slope times time plus the intercept. So the value we're looking at is the speed is equal to the slope, -10 meters per second every second. Okay, times time plus the intercept, which is our initial speed. And we can see it's the initial speed because if t equals 0, the v equals v0. There's another case. So when we want to look at, for example, the time it takes to go from point 1 to point 2, and we can look at the time it takes to go from point 2 to point 3, and we can relate these in a few different ways. So point 2 is where the speed is 0, and we have -10 meters per second every second. Okay, and the time is t12, the time between points 1 and 2, plus v0. This immediately implies that time is equal to v0 over 10 meters per second every second. Okay, so and this is just from the point slope form. The height that it goes to. So this one gives me the time. The height is the area of that triangle. So that's just 1/2 the base, which is t12 times the height, the initial speed. And so now this is equal to, just plugging in from here, 1/2 v0 squared all over 10 meters per second every second. Okay, this gives me the height that is that it is traveling. When it goes up from here and goes up to this point. So this height is what we have right there. Excuse me. Another way, excuse me. Another way to see this and its equivalent is to rewrite it in somewhat a simple, somewhat different way, and that is this height is equal to t12 times the initial speed plus the final speed, which is 0, over 2. This is, in fact, the average speed of the travel going from some initial value down to 0. And so all we're saying is distance is equal to time times average speed, and so we haven't said anything, too outrageous. Okay, so how can we use these again in order to make to do an actual problem? So let's imagine that our initial speed is 30 meters per second. Okay, that would immediately give, so if I throw it up at 30 meters per second, which is about 60 some odd miles an hour, that would immediately give a time between 1 and 2 of 3 seconds. Okay, and that's just from it's slowing down by 10 meters per second every single second. Okay, the height that it would go would be 1/2 times 30 meters per second squared all over the 10 meters per second every single second. Okay, this gives me 45 meters. It is also the same as saying the average speed, which is 15 meters per second, times the time of 3 seconds. That also gives me 45 meters, and it gives me the same thing. So depending on how you want to look at it, it's all pretty much the same. It's the area under the curve, which would be 1/2 times the 3 seconds times the 30 meters per second, or it's the average speed times the time. All of these give you exactly the same the same answer. So I'll continue this in part 2 and go through some more examples.